Alright, so here's something crazy. Turns out most AIs are horrible at real life decision making. I'm talking about the stuff that actually matters: planning, routes, hitting deadlines, keeping deliveries on time without wasting fuel. We always hear that AI is changing the world, right? But ask it to schedule 50 drivers or plan a delivery run across a city and it breaks down like a cheap GPS. That is until now, because what DeepMind just pulled off might actually fix one of AI's biggest blind spots, and if it works at scale, it could change how your groceries get to your door, how your doctor schedules surgeries, even how cities avoid traffic jams. It's like giving AI actual street smarts, and yeah, it's a big deal, so let's talk about it. Okay, so here's the deal: planning delivery routes, scheduling workers, or even figuring out the best way to get supplies to a store is crazy hard. These are what tech folks call combinatorial problems, which just means there are a ton of possible choices and you need to pick the best one without breaking the rules, like making sure a delivery truck doesn't run out of space or miss a time window. For example, let's say a delivery driver has to hit 50 houses in a city, each with a specific time they need their package, and the truck can only carry so much. Finding the perfect route is like solving a puzzle with a billion pieces and doing it fast. Good luck. In the tech world, they call these problems NP hard, which basically means they're so complex that even the fastest computers would take forever to find the perfect answer. Now you might think, hey, we've got AI, right? Can it just figure this out? Well, here's where it gets tricky. AI, specifically neural networks, are excellent at spotting patterns, like recognizing faces in photos or predicting what movie you might like. Based on your history, they work best with smooth, continuous data like images, speech, or text. But when it comes to rigid all or no decisions like planning a truck route with strict timing and capacity rules, they fall short. These kinds of tasks need clear-cut logic and constraint handling, which neural networks just aren't built for. On the other hand, traditional methods that can handle these decisions, like advanced mathematical solvers, are incredibly slow and demand perfect information, which isn't realistic when you're trying to move a mountain of packages in real time. So these researchers were like, we need a way to make AI better at these tough logistical puzzles, and they came up with something awesome: a way to teach AI to think like a human planner, but way faster. They created a trick called MCMC. Layers. Don't let the name scare you, it's just another way of saying they gave AI a tool to explore different options and pick the best one, kind of like how you'd try different routes on Google Maps to avoid traffic. By the way, MCMC stands for Morove Chain Monte Carlo, but let's just call it a smart explorer. It's like a GPS that doesn't need a perfect map. It checks out nearby options like swapping 2 stops or rerouting a truck, and decides if it's a good move based on some clever rules. Here's how it works in a way we can all get. Imagine you're planning a delivery route and you've got a decent plan, but it's not perfect. The Smart Explorer looks at small tweaks, like moving 1 stop earlier or swapping 2 houses, and checks if they save time or gas. It uses a method inspired by something called simulated annealing, which is like slowly cooling a hot piece of metal to make it stronger. In this case, it's cooling the AI's choices to focus on the best ones over time. The researchers turned this into a layer that fits right into a neural network, so the AI can learn from its mistakes and get better at picking routes, all while staying fast and flexible. What's really Cool is that this doesn't need a perfect solution to work. Old school methods relied on something called exact solvers, which are like trying to solve that billion-piece puzzle by checking every single piece. That takes forever, especially for big problems. This new approach uses what's called local search heuristics. Think of them as quick, smart guesses that get you close to a great solution without obsessing over perfection. The researchers made sure these guesses are differentiable, which just means the AI can learn from them, like how you learn from trial and error. When planning a party, they also used something called Fenchel-Young losses. Okay, I know another techie term, but stick with me. It's like a scorecard that tells the AI how close its plan is to the best possible plan, even if the AI only tries one quick guess. This scorecard keeps the learning process on track, which is huge because it means faster training and less computing power. They tested different ways to start the AI's guesses, like starting with a known good plan called ground truth, or a slightly improved one using a heuristic, which is like giving the AI a head start with a rough draft of the route. Now let's get to the juicy part, the results. They tested this on a super tough problem called the dynamic vehicle routing problem with time windows, or DVRPTW, from a big tech competition called Euromeetsner IPS 2022. Picture a city where delivery requests keep popping up all day, and you've got to assign routes to trucks while making sure they hit each stop on time and don't overload the trucks. It's like playing a real-time strategy game where new challenges keep coming and you've got seconds to decide. The researchers use a setup where each truck's route is planned in waves with new requests added and old ones cleared out as you go there. AI powered by these MCMC layers was a rocker when they gave it just 1 millisecond to decide a blink of an eye. It came up with routes that were only 7.8%, 8% worse than a perfect plan that knows all future requests, called the anticipative baseline. Compare that to the old method, which used something called perturbation, basically adding random noise to shake things up, and it was a whopping 65.2% worse. That's like the difference between getting your package in an hour versus next week, even when they gave it more time, like 1000 milliseconds. Their method hit 5.9% compared to 5.5% for the old approach, showing it's neck and neck with the best, but way more practical for real-world use. They also found that starting the AI with a good plan, like the perfect routes from the competition's baseline or a slightly tweaked version, made it perform even better. For example, at 100 milliseconds, the tweaked start got them to 5.9% relative cost, super close to ideal. They played with a setting called temperature, which is like telling the AI how much to explore new ideas versus sticking to what's working. A temperature of 100 was the sweet spot when starting with a good plan, but lower temperatures helped when starting from scratch, to make sure this wasn't just a fluke.